This is a video for the independence of horizontal and vertical motion. Okay, and what this thing is there's a little switch here. Okay, when I turn this on, this solenoid is going to suck that piece of metal in there like that, right? And so what you do is you put a couple spheres. Over the years, I've learned not to call them balls. Put these guys on there like this, and what's going to happen is it's going to push that ball that way, and it's going to pull the pin out of that ball. So one ball is going to fall straight down. Okay, I've got this on back, by the way. There we go. I just realized the plate is right into that one, right? Now, what I do is I just look at the cabinet in the back of the room, and I make sure that the balls are starting the same level. Like that, right? And then for the students, I emphasize really you're not going to be able to see whether they land at the same time, but you're definitely going to be able to hear whether they land at the same time. And you can have students make predictions, like maybe the ball that goes out lands later because it's got farther to go, or who knows, right? So you can have them make predictions. You can have them vote. You could even be, fancy and make like a script where they all have to vote. I don't even know. I just sort of have them show their hands or one finger, two finger, right? Okay. But anyway, we'll turn this on. Let's see what it does. Let's see if we can hear it. And you can hear pretty clearly. You can hear pretty clearly in the video, okay, that they land at the same time, right? And then you introduce the very important principle that horizontal motion doesn't affect vertical motion. In fact, I always give sort of a slow motion replay, right? This thing's moving to the side, but the fact that it's shot to the side doesn't affect the fact that vertically it had no initial velocity, right? So at any given instant, it's the same height off the ground, and it bounces, hits the ground at the same time.